Me. All right. Happy Thursday. We made it. Do you guys have class tomorrow? Or is it like Friday your day off?
Right.
Off? All right. So one of my students has like a math class on Fridays. I'm like, why would you do that to yourself? It sounds terrible. But I don't know. Friday ends up being my meeting day. So I've got an all day meeting tomorrow. And next Friday I have another meeting, but that's my own fault. I scheduled that one. I convinced people that playing Dungeons and Dragons counts as professional development for faculty. So I have a faculty group who plays Dungeons and Dragons, and we get paid to do it. So I'm officially a professional dungeon master, which is very exciting. I put that on my CV anytime I can, turn it in places just to mess with people. It's like you have to turn in your CV every couple of years for their accreditation process. Like, what is this professional dungeon master in your list? Like, oh, let me tell you about it. That entertained me. Right. I got access, everything's all set up now with the grader. We're having some trouble. I screwed it up when I set her up in the GitHub org. So now she can actually go and see all your repositories and get those scored for you. Again, I'd let her know the goal with Project Zero was essentially a practice. Like, can you do the GitHub workflow? Right. It should be pretty much 3 points for everybody here. Project One, okay, one person turned it in already. Great. This again, probably a pretty nice, easy start here. Not the hardest thing in the world. You've already had a year of programming, right? This shouldn't be the hardest thing. Yeah.
Question. So, when you write down like some coding on your application, do you upload them to my Canvas? Because what I do is like usually I just follow you through the YouTube, and that it
Yep.
kind of like takes a little longer.
Yep. No worries. So I do not put code in Canvas because I think that's a stupid place for code. So if you go to my course repository here, all the code is out here on GitHub. This is my public repository. So all the stuff we do will show up here. Not everyone on the faculty agrees with me. That's okay. Right? I don't make the rules, and that's fine because they're a lot smarter than I am for a lot of things here. But Canvas is a terrible place for code because then you have to like download files and copy them and put them in the front. It's awful. GitHub was turned out designed for code. Who knew, right? We can actually use this industry tool and put our code there. So I'll put everything there. I complain about that a lot. I'm sorry. So other people have heard that multiple times.
So you just put it in a cluster.
Yep. Yeah. So all my examples will be in that repository there. Um, yeah. So when I make projects, I'll put them in that repository folder, just like you guys will do for your projects that you turn in. Mine's public because honestly, I don't care if anyone sees it, and it's a lot of work to try and give private access to a bunch of people, and it's just not worth it. Like, I don't care if it's public or not here. I'm just going to throw everything out there. Makes my life a whole lot easier. And then my GitHub profile looks a little bit cooler because I got a bunch of public repositories for all my classes, right? That's very exciting. Um, I don't know, have you seen those jokes about you have like a GitHub commit history here? If you go to your profile, you can see all the days you've committed. So you can see all the days I have classes. Let's see if this loads here. Why is this been so slow? It's not the internet, is it? Is it just my computer? It's getting a little old now, this laptop. Which is sad. They just don't last as long as they used to. There it goes. Yeah, here's your picture, so you can tell like pretty much what days I have classes. Um, Not very many Friday. There are occasional Friday commits when I'm doing something here, but pretty much Mondays. Oh, looks like that semester was Tuesday, Thursday, right, and then back to Monday, Wednesday. So you can see all your commit history, and that's fun. And all my classes are out here, all the ones I have. Cool. So I'm going to do a new project here for week 3. We're going to get into some new stuff. Should be fun. Again, not it shouldn't be anything you haven't seen yet. So apologies. It's kind of a slow start here. We're just looking at how we do these things in Java land here before we get to the fun stuff. So we're going to look at classes and arrays from chapter 7 and 8 here. Um, File IO works pretty much the same way. We're probably going to do more things than you did with it in C++. You did a file IO based project, right? In 150 or 200? Okay. Do you like save a text file and read a text file? Okay. We'll do slightly more interesting stuff, and you can do much more interesting things with it. We won't spend crazy amounts of time on it. We'll do our project on it, but working with the database is much better. So we'll get to database programming here. That's much more interesting than basic file I/O. Some basic file can still be useful. There's some things we want like local files for, but any sort of heavy lifting with files and data, we're going to work with a database here. So just local files. We'll have a little bit of fun with it. I'll show you some of the shortcuts in Java land, which make writing files really quick and easy. So we can take a whole bunch of data here and say write it in with one step. We don't have to go through all this convoluted process here. And we want to read it back out. We'll just read it in one step. It works out really nice. So we got some cool shortcuts. Object-oriented programming, we'll get to some of the more advanced pieces here when we get, so we're going to talk about classes today, and then again, a little more of the advanced bit here. We'll spend a lot of time on graphical user interface applications. This should be fun and something new. I don't think you did any of those in C++, right? My Python class did. If you came from Python, we did some graphical user interface applications because it's easy in Python. It's a little harder in C++, not the end of the world. And then a bunch of advanced stuff. We tackle a bunch of chapters. We're not going to go crazy deep on all of them. They're somewhat shortish here. And then our last chapter, we'll finish up with databases here from the textbook. So if you did notice already, thank you for noticing. I did post the quiz. These do come out of the publisher's quiz banks. So I didn't write the question. My apologies. They're probably good, decent questions. I don't know. They're multiple choice. Should be pretty easy. This one was all together 4 through 6 already. So I skipped chapter 3. I said 1 and 2 were really boring for a quiz. The other ones came chapter by chapter. So when we get into some of these other chapters, you'll have 1 quiz per chapter. They're not timed. Like this one wasn't bad, right? Anybody who took this one, it was relative. I mean, 30 questions, but relatively quick, right? Okay, so again, these are your incentive to read the book. So I'm going to give you examples. The book will give you examples. Right? You're going to practice a bunch of things. You're going to do homework. So you want to get this multiple times to get familiar with it, to get comfortable with it, get good at it. So if you open the book, you should be able to answer these questions. Okay? If you don't have the book, meet up with your buddy that you introduced for the first project, read their book. Be like, hey, can I borrow your book? We do this quiz. Please don't take the quiz at the same time. That would make me sad. Okay? This is your individual effort. Okay? It's not hard, I promise. You don't need someone to help you with this, please. Like you're all intelligent people. You made it this far. You can answer these publisher test bank questions, I promise. Right? No, there were no gotchas in chapter 4 through 6. Right? No one complained that there were trick questions. Yeah,
Oh, sorry, I just got here.
it's okay.
Actually, I'm gonna, I think question 4 is tomorrow.
We can take a look. Which one?
Yeah,
Did it shuffle? I don't know if it shuffles or not here. Let me I click. My goodness, there's a preview button.
say coding file.
Preview.
Yeah.
I have to go to build, right? I can't preview. I
There's one
build it.
that's like a count was equals to.
Oh, no. So they all come from a test bank. So I don't know what your question 4 was. I'll have to look at yours. So we can chat on break or something. Um, yeah, if you got questions about them, let me know. Yeah, because they come test bank. So they shouldn't even be the same 10 questions for each of you because they come out of a test bank. Hopefully, right? It should be pseudo random at least. You know, as random as we can get here. It's probably fine. So we'll take a look at that after we can chat and pull up the individual question here. But again, so the next chapters then we'll just do 1 quiz per chapter. They're just 10 questions. It should go pretty quick here. Again, it should be free points. You shouldn't get any of them wrong because it's not timed. It's not like you have 10 minutes to answer it here. Just start it. Look at the questions before you even do your reading, right? That's a nice tip here. And then as you're doing your reading, like, oh, I remember I had that question, right? Open it, close it, come back to it, save it, whenever you want. Get it in. Ideally by 11:59 p.m. tonight. I didn't post this one early enough, so if you need another day or 2 on it, feel free. Like I don't particularly care if the quiz is late for this one. The rest of them, I finished the import process, and I'll turn them on after we finish them. So ideally, you're staying up to date with them. Again, it's your incentive to read the book here. It should go well. Now, something nobody noticed, which is embarrassing for me, but also that there were almost 40 of you the first night here when I read you the syllabus. I didn't notice my math error here, so you can all be embarrassed too, not just me here. But when you look at this here, does this add up to 100%?
Oh.
Nobody noticed, not even me, until I went to plug it into Canvas. So
That's because you're more focused on the knowledge than on the grade.
you're here for the knowledge. I love it. I love it. You don't get free points for making me feel good. Yeah, good try, good try. So I did change that here. I didn't update the PDF yet because I wanted to show you folks. So I thought the best place to put those extra points were in projects. So instead of being 30%, your projects will be worth 40%. Your quizzes will keep at 10% because they're basically free, right? I shouldn't be giving you 20% of your grade for free. 10% I'm okay with. And the midterm, I don't want tests to be worth a lot because I think tests are stupid. But if I don't put tests in my syllabus, I get funny looks. So I have to put a test in my syllabus. Mostly. Again, sure. So yeah, left the midterm at 10%. I just increased the project score. Hope you're okay with that. Okay. And I didn't give you anything new. I didn't want a new category either. And then a few people noticed I just added a syllabus quiz. This is just a 1-question quiz that has you agree to the academic integrity policy. Okay. It's really my CYA so that when I fail someone for cheating, I can turn in the quiz that they've agreed to the policy and my syllabus that has the policy and their plagiarism, and then they fail. As I have to do a boatload of paperwork to fail people, turn it into the dean's office. It pisses me off, and then I'm all cranky for the day, and then my wife is cranky that I'm cranky. And she's like, "Why are you mad that they're cheating?" I'm like, "Because they're stupid." Like, it's not hard. You don't need to cheat. I promise you. You've made it this far. I'm assuming you haven't cheated your way through 150, 200. And possibly that's a bad assumption. But I'm going to assume no one has done that here. Uh, you can do this work. Okay. You just have to put the time in. Right. I get there's pressures to get good grades. Most of your grade comes from do it yourself at your own pace stuff here. Right. If you're putting the time in, you'll get it done. Okay. If it doesn't make sense to you, please ask me. I don't know if it doesn't make sense to you until you tell me that. So one of the reasons I get paid is to answer questions, or I'd like to imagine that, right? You could watch a bunch of YouTube videos to learn how to program Java, and they're probably higher quality than I can do anyway, right? They actually like put production in and have fun cut screens and have little fallouts and whatever, right? I'm showing examples. That's the best I can do here, but I can't make you learn it. You got to go out and learn it on your own and put the time in here. So I'm impressed a lot of people showed up. We only had 3 people right at like 6 o'clock, so this is good here. Usually the class gets smaller and smaller and smaller as we go because I don't take attendance. They don't get points for stuff for showing up. Um, so yeah, great. I'm glad you're here. Ask questions. Stop me anytime. I've had a lot of coffee and caffeine already, and I'm switched to Coke because I couldn't get coffee yet here. I'll go get some at our break, and we're just gonna have a lot of fun. Because ideally, you think coding's interesting at least, right? If you don't find it interesting, you picked a bad major, right? Because you're gonna be doing this for 40, 50 years, right? Because they keep by the time you start working and the retirement age keeps going up, you're coding to your 70 at least, right? No one's gonna retire early. But you'll be lucky if you paid off your student loan by 70, right? Is that the story here? I'm sorry, that's depressing. Should we just ignore that? All right. So new stuff here. Let's start with classes. So I'm going to make a new project again in the public repository. You make your projects in your project repository. If you want to put other stuff there, go for it. I don't care. Put your notes, your practice stuff in Git. Go for it. I'll ignore anything else in your repositories, or just make your own, which is probably better because then you have full control over it. The repositories that the GitHub Classroom links make for you, technically I own because it's in my organization. I have no plans to delete them, and as long as GitHub doesn't make me delete stuff, and they've given me unlimited space essentially here, so I will take it. But if at some point they limit that space, I will start deleting old stuff from years ago. So uh, probably better to have your own copy, but feel free, put whatever you want in there. This semester it should be fine. So let's call this week 3. This was what classes and arrays, right? My goodness, I can't even remember. We just looked at this here. Excuse me. Yeah, classes and arrays. Perfect. Okay. Classes and arrays. Capital A and looks awful there. That's okay. I don't want to Git repository, right? Don't put Git inside of Git. You'll get confused. Um, starter code, great. Sample, that's all fantastic. I'm going to delete everything anyway, but at least I get a main Java file. I don't have to make my own file, right? If you wanted to do it all by hand, you could here. You're more than welcome to do it the hard way. Right? If we had nothing here, right? And we could even get rid of our main Java file if we wanted. That's fine. So I'm going to go add a new Java class. We'll just call this week 3. Why not? And because all of your good IDEs know that Git exists, it will warn you and say, hey, do you want to add this to Git? I just ignore it every time. I probably should check this box that says don't ask again, but then it doesn't show up and you won't see it show up when I show it to you. So I just hit cancel every time here. So the name of my Java class matches the name of the file. Letter for letter, case for case. Right? It has to match that. And thankfully it gives me the public class here. The piece it doesn't give me is the public static void main string args. That's okay. It's not worth remembering here. It's PSVM tab. We'll autocomplete that for you here. One of your Java files has to have that to make your program runnable. Right? When we compile our Java code, the Java virtual machine says, where's the main method? And we'll run the main method. That's how it starts. When we write other classes, we don't need a public static void main because they're not runnable. Right? I'm just writing class code that can be used somewhere else. Okay. So that's my ring alarm going off. Now I think you all were pretty good with the popcorn questions. When we talked about object-oriented programming, some of the principles of object-oriented programming, we had 3 fun words we love talking about because fun, fancy words make us sound important and intelligent. Remember your 3? Inheritance, polymorphism, encapsulation, abstraction. The polymorphism and, my goodness, yeah, inheritance, abstraction, encapsulation. So sometimes like inheritance and polymorphism, we do kind of together. But yeah, so we could have 4 terms if you like 4 terms. Usually we just say 3. Um,
One abstraction.
so abstraction means we're going to deal with things in an abstract manner. That's what we're about to do when we write classes. So my class will do something, and someone can use that class abstractly. They don't need to know how it does it. They just need to know it does what it's supposed to do. Like when we use the random class and we imported random, we got random numbers. I don't actually know what Java does to generate the pseudo-random numbers, but I don't care, right? It tells me it gives me a random number. I say thanks, right? The details I don't know because it's abstract. Now we could go look because it's open source. We could go see what it's doing here, but we don't care, right? Most of us don't care what the random class is doing. It's a fun academic exercise. You want to go look at it sometime, but we don't particularly care, right? So we write our classes. We want them to be abstract in that they have public methods or functions. Technically, they're different, but I've never understood the difference. I always use the words interchangeably. So if I call it a method, it's a function. If I call it a function, it's a method. Um, Best I can tell, they're the same thing here. Um, that public functions, public methods, are used to do what they say they do. Right? Now, we're going to know the details because we're going to write it, but we don't need to expose those details to the class that calls it, the class that uses it. Okay, so if we want to go write a class, I'm going to go add a new Java class here. Let's do the silly example of chair here. Let's do a chair, right? When we talk about objects here, they tend to be the nouns, right? And then they have a list of attributes, the things about that instance of that object, that noun here. Things like how many legs does it have? How tall is it? What color is it? What fabric is it made out of? Does it lean? Does it go up and down? Does it, I don't know, is it an expensive chair from Aaron Miller? Sure, right? Anything we want to have here. We can have as attributes of chair. And then the things that chair does are its verbs here. Those are its methods. So what do you do with the chair? Oh, you can raise your chair up. You can lower your chair. You can tip the chair back. You can tip the chair forward. Some of those chairs have like 7 different knobs. You can add lumbar support, right? It depends how much money you spend on your chair, right? Um, your chairs don't move at all because, of course, we don't give you decent chairs in this room, despite how much money you pay in tuition. You can have these hard chairs, sure. Um, it's not the end of the world, but you can survive a couple hours in that chair, right? Mine has barely any padding in it, which is sad. Come to appreciate padded chair much more lately.
That's
Yeah.
what
Okay.
if we need public class and just a class.
So classes don't have to be public. In Java land, you get 1 public class per file. You can have more private classes, but they're not going to be publicly accessible. So if you want to make code that another class will use, you want it to be public so it's usable. If the only time you're ever going to use that class is within another class,
Yes.
you can make it private. We'll talk more about that when we get to like the object-oriented principles. Putting classes inside of classes, you can definitely do it. It gets to be a little awkward, but sometimes it helps save some time.
So like for the project 1, I can have a just class Powerball. You just call it within a public class, whatever.
Sure. Yeah, you can put a class inside a class. Yes, lots of ways to go about it. So I would argue when we're designing solutions here, the nouns could be classes. They don't have to be classes, but they could be. Do we need a class for like ball that has a number 1 to 69? Probably not. That feels like a lot of overkill. Now you could write a class for ball and it would have an attribute of the number, and we make 69 instances of them and put them in a bucket and pull them out. Or we could just have the numbers 1 to 69, right? Like we're not really adding any functionality there, but making a class for ball. But you could. But like the ticket itself, here, a Powerball ticket has 5 numbers, 5 white numbers, 1 to 69, right? It has the 6 number, 1 to 26, the red ball, and then it has things you can do with it, right? You should be able to take a ticket and compare it to another ticket or the winning ticket and tell you how much money it wins. Now, you don't have to write your code like that, but that's how I'm going to do it because I think that makes a lot of sense. And designing it is easy that way, right? So one ticket can compare itself to another ticket. Cool, right? We can just say, here, ticket, tell me how much you won, right? We don't have to, you can do the logic other places here, perfectly fine. We'll get the job done. But there's ways we can go about it. So with our class for chair, we're going to list out our private attributes. Now, some people say put them at the bottom. Some people say put them at the top. I've always put them at the top. But sure, it doesn't really matter. Pick somewhere. You can mix and match. You can put them in the middle of your file if you want. I don't recommend that because, again, if you make code hard to read for people, they're going to be upset at you, right? Don't make me upset at you, right? Because I'm giving you your score. I guess the grader is giving you a score. Don't make it hard for the grader to read your code. Don't make it hard for you to read the code here, right? And don't make it hard for the person who comes after you to read your code. Now, this is throwaway stuff. You're not going to keep these projects here. They're not very interesting. But you want to be able to remember what it's doing the next day. So with our good object-oriented principles, where we want to be abstract and not give away a lot of details, right? We want to encapsulate all the details here into one nice little package. So we're going to encapsulate chair into a chair class here, and we're going to make sure that they don't have access to things they're not supposed to, right? You shouldn't be able to go directly access my attributes. I'm going to give you public methods to do that, but I'm going to make my attributes private because I don't want you to change them, right? This sort of idea, if I keep all the details nice in a nice little package and don't let you change them, you can't break it. Right? A class should make sure that it maintains its integrity. So if my chair class, can't have 27 legs, I'll make sure in the code it can't have 27 legs. Right? That was a little bit silly. We'll look at height. We'll probably have restrictions on height. So I'm going to list out private attributes. So inside of my public class, I'm going to list all my attributes. They can be public. We generally frown upon that. That tends to be a bad object-oriented practice to make public attributes. Now, again, it's a lot more typing this way, but we're going to see some shortcuts, so you don't have to do a whole lot of typing. I promise it's not so bad. So we'll have a private, maybe a string for color for my chair. We'll have a private string for manufacturer.
Like you're saying with your private because you don't want people to be able to change them.
We're not going to give, there's no direct access to them. So we're going to write functions, methods that give people access to them that we'll have control over because we don't want them to be changed. Or we want to control how they're changed. So we'll have more control over it by making them private.
Okay, well, you're immutable within the scope of the class.
The class itself will have access. So anything inside of chair will have access to them. Outside of chair, you won't have access to them. Right? And then we'll have a private, probably int for height. Now, anytime you have a unit of measure, you should tell me how you're measuring it. Because most of you would probably assume height is in inches. And I would argue the imperial system of measurement is awful. We're going to do the height in centimeters because the metric system is far superior. So I'm going to have height in centimeters. Now, I usually don't use abbreviations, but spelling out centimeter every time, I make a lot of typos. So if you're okay with me saying cm, that's probably pretty well recognized here for centimeters. I'm going to be okay with it and feel a little bit bad, but I don't want to type out centimeters every time. Or I mean, even if it auto types here, I just make typos a lot here. So height in centimeters. Now, we're also going to have assuming your chair can go up and down, not all chairs can, but some chairs can go up and down, we'll have a max height in centimeters, and we'll have a private int for the minimum height in centimeters. Now, this seems a little bit overkill, but in a chair like that, that's got a little lever over there that can go up and down, it has a maximum, it has a minimum, right? That's a valid attribute for chairs. Now, chairs that don't change, their height, max, and min will all be the same, right? Makes sense. It's just the same number. It's not a big deal here. And then,
should we have like a recline?
Yeah, we don't need too many for this exercise. I think this is probably enough for now. You could have does recline, has lumbar support. You could have a gazillion attributes. Like if you look at those Aaron Miller chairs, they're ridiculous, they're really nice to sit in. It's like sitting on a cloud. And if you sit for 8 to 10 hours a day, it's nice to have a decent chair. You spend more of your life in your work chair than you do in your bed most of the time, right? Like we should spend a decent amount of money on our chair. I'm not saying you have to go out and blow thousands of dollars on a chair, but more than the $50 chair from Staples or something. All right. So we got some attributes. Now, if they're private, we have no way to set them here. So we have two options. Right? One, we can accept them in the constructor or the init if you come from Python. So our constructor method can accept the values here. Now, some of these things I'm going to argue should be immutable. They should not change, and some of them can change, right? Can you change the manufacturer of your chair? Yep. Once it's made by a company, it's made by that company. Can you change the color of your chair? Yeah, I mean, you probably don't want to paint your chair, but you could, right? Or you could put a little cover over it here, right? A little slip cover for your chair. It changes the color. So color is mutable. Manufacturer is not, right? Your max and min height probably don't ever change, right? I imagine that's probably difficult to change in a chair. You can probably get a different size piston or something for the up and down motion. I don't know. Have you ever changed out the piston for your chair? No. Okay. So we'll say those are probably immutable as well. So anything that we want to be immutable, we have to take in the constructor. Okay? That's the only way to set it because we don't give you a public way to set it. We don't want a public method that says, hey, you can set the manufacturer because you shouldn't be able to do that. Right? When you make a chair, you're going to tell me who made it and it's fixed forever. So constructors have a fun syntax. So we looked at methods before, right? We said everything was public static. And we're going to get rid of the static keyword. Now we're talking about classes. We'll come back to it in a little bit. But for classes, we don't want them to be static because I want access to these attributes. These are not static attributes, so my methods that interact with them can't be static. We'll do some static examples after, but just set that aside for a minute here. So it was public static and then void or the return type. Right? Void if it didn't return anything or what type it returned. For the constructor, nothing's returned. We omit the return type. So you can have private constructors, but that's way more complicated than we want to get into right now. So we're just going to have a public constructor called chair. So public chair, notice there's no return type on constructors or init here. Now inside my constructor, I can set a bunch of arguments, right? So at least the things that are immutable, we need to put in here, right? And you probably could tell me what color it is when you make the object, but we still give you a way to change it. I'm a big fan of taking arguments in constructors, so I'm going to take all of these arguments essentially. Now, it feels like a lot of typing here, and yeah, it is a lot of typing. So I can go to generate here. So if I right click in PyCharm, I can go to generate, and you get a bunch of options here. So I like the constructor option. It says, all right, choose what field to initialize by your constructor. Which attributes are we initializing here? And I want all of them. So I'm going to shift click. You can click individuals, but then it moves them. So you could like control click to pick alternating ones or, from the top, shift click down to the bottom. Any way you want to pick all of them. Great. Here, I'm going to say OK. And it automatically gives me my constructor that takes the arguments, a string for color, a string for manufacturer, an int for height in centimeters, an int for max height in centimeters, and an int for minimum height in centimeters. Again, it's a little long. I'm zoomed in a little bit, but I'm going to move that down so I don't have to scroll right and left. That makes me feel happy. I'll slide that over a little bit more. And then we get this fun little syntax. So it is this dot color equals color. And notice they're in different colors here. So this one's a little bit purpley here. This one's in white. So what we get here is color the argument here. And this dot color is color the attribute of this. This is an implicit this instance here, kind of like a pointer. You might have done some pointer work in C++ with this. Same idea here. So this dot color is this instance's color, right, to the argument color. So just be careful. Now, some people say don't use the same word here, and then you don't have to worry about it. You don't have to add the this. I think that's dumb because in my IntelliSense, when I want to go use chair, I don't want it to say C, M, H, M, M. Like, no, that means nothing here. I want the full name of the arguments because they show up here. So I want to go make a chair. Chair, my chair equals a new chair, right? I get chair. Come on. Thinking about it. There we go. I see string color, string manufacturer, string height in centimeters, int max height in centimeters, int minimum height in centimeters. I get the list of arguments showing in that IntelliSense. So if you put C, M, H, M, N, whatever here, that's what garbage you're going to see here as well. Now, you could go and add a Java doc comment and add the documentation here so you get the nice looking IntelliSense, like we did with like the random library, right? If we imported random or scanner, right? We'll import scanner. Why not? Just import scanner, sorry, java.util.scanner, and then we can make a new scanner here in a second. And again, I like calling it keyboard. You can call it whatever you want here, doesn't matter. Scan system.in, right? We'll use our standard input. In this one, we get the full documentation because they added a Java doc comment. If you can get this far in coding, I promise you can read how to write a Java doc comment. I'm not going to bother and waste your time, right? And I just dislike doing them anyway because I don't write libraries. Bless you. So you see, hey, here's the parameter for source. And this could be a S up here. But again, that's obnoxious. So we're not going to bother with that. So we get chair. So we need to give it a bunch of things. So the first one was the color. What color is my chair? This looks blue here. The manufacturer of this chair, I have no idea who made this chair. I don't know. I'll just put Toyota. Sure. Toyota. What's the Suzuki? They make pianos and motorcycles and appliances or something like that. They're a crazy manufacturer. Or Yamaha, right? Are they the motorcycle and piano play people? not Suzuki. Uh, yeah, people, I don't know, companies make a bunch of weird stuff. And then a height, right? So this one is fixed here. It's probably, what is that? I don't know, maybe 2 feet, foot and a half here. So that's, I don't know, we'll say 60 centimeters. I don't actually know if it's 60 centimeters or not, but that's okay. We'll just assume that's close enough here. So I'm going to give it 60 for all of them here because it doesn't change. Okay, so now I've got my chair here and I've called it, I've given my values. Now this color colon, manufacturer colon, that's all coming from IntelliJ. I didn't actually type that and it doesn't actually exist. Right? There's not actual text there that says max height here. I've had people ask me, they're trying to follow the video and they type color colon blue and they get confused why it's not working. Right? It's not actually there. This is just IntelliJ trying to be helpful here because we know now what those values are here. So I can make my chair. Now, I have no way to access these values after I've set them, right? We need get methods to go and get their values out. So again, I'm going to use the generate method here. Um, if you use generate to create your constructor and your set and gets, I could care less because they're all going to look exactly the same no matter what here. You don't need to cite your source that, hey, I clicked the generate button here. It's not AI. It's been around for lots of years, way before these AI related tools have come out here. So when I ask for you to cite your source, if you're giving me code that's not yours, this is one of those exclusions, right? Because this will look identical for everybody every time, right? Unless you give me terrible looking letters, and then I'll just make fun of you for bad variable names. You won't lose points if your variable names are bad, but I'll just make fun of you because you gave me bad variable names here. You can do better. Right, so we're going to right click and generate, and you probably saw, hey, there's getter and setters. So I can generate getter and set methods here. Now, again, I don't want all of these to be set here. So I really actually only need that for color because none of the other ones I want to be set here. You shouldn't be able to change them directly. So we'll have color and we'll generate a get color and a set color. So get color, public, string, because it's going to return a string called get color, and then it returns the instance color. Now I don't need the this dot here because there is no argument color for it to get confused on which one is which. So it just returns color. You'll notice it's in purple, right? Purple are my attributes here, class level attributes. And then set color takes a color argument. So then it calls this color equals color. Excuse me. Now, something you can do if you wanted, and again, I usually say anytime you have the same code twice, you should feel bad about yourself. That's a pretty good rule of thumb. And right now I have the same code twice. This color equals color, and this color equals color. Right? So why not make my constructor use my method that I just wrote here? So I can go and change this to set color, given the color. And now I don't even have to use the this keyword. Right? Now, again, I had to go do a little extra work here. So if you leave it, it's okay. You don't need to feel bad. It's perfectly fine to leave it. But anytime I have a set, I like to use the set in the constructor. That's just what I like to do. Okay, so we've set our color. We've gotten our color. Now we need the rest of our get methods here. So I'm going to go generate and say getter. Here, I want everything else. Now, it took color out of the list. It's smart enough to know it already made one for color. Isn't that cool? These tools are amazing, right? They're written by developers for developers, and developers are lazy. So we're going to make all the cool shortcuts in our tools for other developers because we want to be nice here. We have all the gets: get manufacturer, get height in centimeters, get max height in centimeters, get minimum height in centimeters. Typing that out by hand sucks, right? You probably had to do that in C++, right? It's a big waste of time. This tool will do it for you. You don't even have to ask AI. Now you could go and ask the AI tool to generate them for me here, but then you've used a bunch of power at someone's data center to do something that this tool did in 2 clicks, and you should feel bad about it, right? Don't waste electricity, but that's okay. So we've got our constructor, we've got our gets, we've got our sets. Now we don't have a way to change our height though, and we should be able to change our height in a chair that's height is changeable, right? So I'm going to make my own method. I'm finally going to do some of my own work here. So we're going to add a method here. So I'm going to have a Boolean here. I'm going to return the true or false whether or not this worked here for change height. And then what do I want here? I probably want an integer for change in centimeters. So you tell me how many centimeters you want to change it here. So if you go positive, you're increasing the height. If you go negative, you're decreasing the height. Right? We could add a increase height and a decrease height, 2 different methods here. Perfectly fine. However you want to write your methods, go for it. Right? It's up to you. You get to design this chair any way you want here. But I like, you tell me the change, and then you just give me positive or negative. Now, some people might not realize they could give you a negative number, and they'll only ever make their chair go higher and higher and higher. Okay, sure. So maybe having some sort of note somewhere might be nice. But again, it's okay. It's just for our own purposes. All right. So change in height then is going to take my height, and I'm going to add to it the change in centimeters. Oh, I'm sorry, height in centimeters. Here we go. Height in centimeters plus the change in centimeters. But I've just done a bad thing now, because if you told me you wanted to go 100 centimeters up and your chair has a maximum that's lower than that, we've put our class in an invalid state, right? This is a big no-no. Like, one of the class's jobs, one of the reasons we encapsulate all those details together is to protect its integrity. You should not be able to put a class in a bad state here, right? That's one of the class's jobs, is to maintain its integrity. So we need to check that. So we need to say, hey, if my height in centimeters plus the change in centimeters is less than or equal to the max height in centimeters, then I can go do it, right? Cool. And then I'm going to return true. Life is good. If it's not, I'm going to give you back a false, right? I can return false. That's illegal here, right? What else have we missed here? Is this good? Or we missed something? What about going down? Well, we got a minimum too, right? Okay, so adding to it, yes, should be good, but we should also make sure we're not going lower than the minimum, right? So we just and together here. So and then my height in centimeters plus the change in centimeters is greater than or equal to the minimum here. Remember, this could be a negative number, right? So adding a negative, you're all at least through Calc 2 by this point, right? Here, you know how to add a negative number. So we should still be above the minimum or equal to the minimum, and then less than or equal to the maximum. Before we make that change, then I can go add it, and I can return true. Life is good here. Notice I don't have an else here. It's redundant, because if you return true, your method's done. It stops. You're never going to get down to the return false line here. So adding the else is just a bunch of extra typing here. So if we didn't satisfy this condition, we're going to tell you, no, that didn't work. You can't change the height, right? Does that part make a little bit of sense? You make this true or false? Now, this is one option, having a Boolean here. If we wanted to be more forceful, we could throw an exception, right? We talked about exceptions last week. Okay, good. I was afraid we didn't for a second there. So if you just want a nice yes or no that worked or not, cool. If you want to be more forceful and then say, hey, you tried to put me in an invalid state here, that's totally bad, fix it or crash, you can do that. And we're writing the class, so it's up to us. So this is one option here. So this is the, I don't know, nicer way, just returns yes or no. Worked. We can do it again. Here, I'll leave all this commented probably here. So control slash, there we go. And we'll try it again here. So this is just public void change height, right? I'm not going to return anything here. Takes an inch change in centimeters. So if it was good, then now too many comments. That's right. Goodness. So control slash. Okay, we'll get rid of those here. Now don't return anything here. Now there's a couple schools of thought on how you approach these here. The most common approach here, we have our guard clauses that throw conditions, that throw exceptions, right? So we're going to check to see, hey, if it's invalid, I'm going to throw an exception here. So if the change is greater than or equal to my max height, I'm sorry, greater than the max height, because equal to should be fine, right? Or it is less than, no. Did I do that wrong down here? That was okay, right? This one, no. Okay, I'm flipping it because this is the negative case. So it was greater than or equal to matches, right? But if it becomes less than the minimum, we're invalid here. So we're going to first check, this is a guard clause, we're checking invalid state, right? If this change would put me in an invalid state, I can throw a new exception. So illegal argument exception is probably the nice easy one to use here, right? Invalid change. I don't know, or we could be specific, or I don't know, whatever you want here. You give details here. We'll just say invalid change. Again, feel free to give more details if you want here. Oops, throw new. Yeah, missing the new keyword. You have to create an instance of the illegal argument exception class to throw. So we're going to guard it here. If it's bad, throw an exception. Otherwise, continue on. Life is good. Let's keep going. Right. So this is the most common approach, having your guard clause first, rather than check and do something. If it didn't do that, throw later. So you want to generally have your throws early. Right? So as you're reading someone's code, you see, oh, real quick, oh, this is bad. We did a bad thing here. quickly at the top when we're scanning, not have to look your way through and see 3 different throws here in the middle, at the top, and at the bottom. Like, that gets kind of confusing when you try and follow someone's code. So just it's a good habit here, not required, but just a nice habit. Okay, so now when I try and go use it here, let's take my chair, change height, I don't know, 5. Cool, life is good. I can go run it here, and this one should crash on me, right? Because I can't go higher or lower, right? When I go and run my program here, it's got to build. Is that the first time running it? Wow, it's the first time we ran it. I get an illegal argument exception, invalid change, right? So again, if we wanted to do something about it here, we could use a try block, right? And try it and catch an exception and maybe put it inside of a loop or whatever we wanted to do here for that, right? But having our class throw an exception is forceful here. So this is the forceful approach. Using exceptions, right? Fix it or crash, right? Rather than just, hey, it worked or hey, it didn't work and hope someone paid attention. It kind of depends. However you want to write your class here, up to you. One way or the other, right? For Powerball, validating we had random numbers or numbers without repeats, you could just return false and say, no, it doesn't work. But then if you've returned false, they have an instance of Powerball in an invalid state. Right? If the constructor sets 5 white numbers and there's a duplicate there, your jackpot calculation is going to be screwed up. And now you've given someone more money than they should, and the lottery doesn't smile upon that. Right? The state lottery system doesn't exist to give out money; it exists to make money. And if you start losing money for the states, you're going to be in big trouble. Right? Someone will be unhappy. Okay, so if it puts it into an invalid state that can't be used, you definitely have to throw the exception. Right? You don't have the option to just, oh, hey, by the way, you gave me a bad number. Please do something about it and accept it. Right? So it depends on what we're working with there for our classes. Right. So we've got our constructor. You can do default arguments with a constructor again by overloading. So if I wanted to say, hey, if you have a chair that doesn't change the height here, we could take this chair here. I'm just going to steal that one here. This chair constructor then will call the other chair constructor, right? And we'll just substitute height in centimeters for the max and min. So I'm giving the person using my class the option, instead of having to type in the same number 3 times for a chair that doesn't go up and down, you just give me the number once, and I will plug that in for you here. So I can then say chair, color, manufacturer, height in centimeters, height in centimeters, height in centimeters. Oh goodness. Oh, is that new? Is that not the syntax? More options. I want new. This? My goodness. No. Oh my goodness. That really should have worked here. My goodness. All right, let me Google here. Java loaded constructor. I don't remember. Probably in our textbook somewhere. Constructor overloading. Oh, it's only the this keyword. Okay. I can't remember all these between different languages. My apologies. So it's just this here. So this says, go call yourself your own constructor here because you want this instances here. We use keywords weird places here sometimes. That's okay. So we're saying, hey, go call the other constructor, right? The overloaded constructor here. So overloaded constructor. Okay, so we've got more than one option, right? So if we want to make another chair here, right, I can get rid of this one that doesn't use this one. I can just pass it these values here, not with that comma, or I can make a chair. Eric's chair is a new chair. My chair at home is black. It was made, I don't know, by someone at Staples. They don't have their own brand here, but we'll just call it Staples here. Probably starts at 60, goes down to 30 and up to 100. I don't know. We'll just make up some numbers. Doesn't matter too much here. And now my chair should go up and down here. Chair, I can't spell here, without crashing, because that should be valid, right? Oh goodness, no. Eric's chair dot change height. Change height. There we go. Let's try changing the height of my chair here, and that one shouldn't crash here. Eric's chair? Did it actually crash on me? Or is that the old? Okay. Well, we did a bad thing then. It's crashing somehow and it shouldn't have crashed, right? Oh, flipped those around. Max first, then min. and I gave it min and then max. Probably want to check for that. Maybe? Is that what we want to check for in the constructor so people don't do dumb things? Why not? We can check for it. It's our constructor, right? So again, we'll put our guard clause first here. So if my max height is less than the min height here, we can throw a new argument exception. Oops. Legal argument exception, invalid min and max, right? And then maybe even check what the current height is, right? Make sure we don't start with the current height too high or too low, right? So we can do another one, right? So if the current, oh no, just height in centimeters is less than the min, or the height in centimeters is more than the max, throw new legal argument exception, invalid current height. Again, you could be specific. We could do one for min, one for max if you wanted. Sure. If you can do one, you can do more than one, right? We'll add two little guard clauses here. If they're good, then we'll keep going. So now my error should make a little bit more sense because it technically, I mean, it shouldn't have been an invalid change, but it was invalid min and max here was the cause of that being an invalid change. I totally did that on purpose so you guys would see this, right? Definitely on purpose here, maybe making typos. So let's fix that to 130 and try it again. And then our code should work. All right, happy. I mean, it doesn't do anything. We didn't do anything interesting with our code. We changed it, but that's okay. Now, in Java land here, one of the common methods that you'll have here to turn something into a string, like if you wanted to print out that, is toString. So right now, if I just print out here, so Eric's chair, right, we're going to get garbage here because we haven't defined how to print this as string. So in Java land, every class inherits from the class named object. The class named object has a method to turn a class instance into a string. It gives you the name of the class and, best I can tell, the memory address of where that's stored. It probably is. I don't think it's all that important, right? But sure. So it'll print that out. So but this is not helpful, right? When you said print Eric's chair, you probably didn't want that. And you probably wanted some details about it here. So to do that, we're going to come back to chair. We're going to go generate a toString. So toString is the method that we want here. And it says, hey, what should we do? We probably want string concat here. We could also take the string concat and a superclass toString. We haven't done inheritance yet. Don't worry about it. We'll get to it in a couple chapters, but works the same way you've done inheritance before. You know, it's not very new. But for now, let's just concatenate it all together here. That's probably fine. And look at all this code it gives me. I love it. Okay. And it's using this annotation to say we're overriding here the toString method. This annotation is helpful because if you typo something here, be like, oh, it's toString. Now your override says, no, you didn't. You meant to override something you didn't, you dummy. You did it wrong. So it's not required, but it's helpful because it gives us more checks in our IDE, more checks when we compile, right? So if you forgot that it should be a lowercase t for toString, it would let us know we did it wrong. Again, we're generated it here, not exciting. You are welcome to generate these as much as you want here. You don't need to cite the source. It looks just like this. It's not very exciting here. I know you just click the button. Feel free that, but most of the time this toString isn't even all that helpful. Like this is usually not the output we actually want, right? Because this looks a whole lot like code. It actually gives you like a JSON looking format here. Maybe not exactly like, yeah, I guess that's JSON-y, right? Here's their attribute, here's the value. Yeah, so it gives us like some JSON looking output. It's a chair, that's my class, and here's all the attributes here. But now I can see all the values, right, which is exciting. The other way I'd have to do this, to look at my values, which is fine, use your debugger. You guys all love the debugger, right? That's your favorite tool for getting through 115, 200, running in debug mode. Works the same way. We could run it with the bug here to put it in debug mode. Oops, I clicked too fast. Run it with the bug here, and I can see all my attributes. Now, because I added that toString, I get that preview here, which is really nice. So if you add a toString, you get to see that in debug mode, which is phenomenal, right? Here's the string representation of that class. You don't even have to go open it and look at all the attributes, but you could. Right? We could open and look at our attributes here. Great. The other fun thing in debug mode, we can go change things here. Can I change it? Set the value. Set it to orange here. So I'm going to change Eric's chair to orange. And when I step over and print it out here now and look at my console, I now have an orange chair. So in debug mode, you can change values on the fly as well, which is really fun. Right? You can make it do bad things. Right? Again, or just run it through testing here. right? So we feel pretty good that chair does what it's supposed to do. It's protected the integrity of the class. We've encapsulated all of our details. When you work with it in the abstract method, right? All you need to know is you can change the height of a chair. You don't need to know the details of how that works. I mean, sure, that one's easy. It's arithmetic. But again, as our classes get bigger and more interesting here, here's a public method. It should do as advertised, and no one needs to care how, right? Makes life good. So we don't need to know how the libraries work to use the libraries. Okay. Now we went through a bunch of manual testing here, and if you remember anything from last week, we're bad at it. People are bad at manual testing. Right? At least some of this basic stuff here. Your QA testers are phenomenal people. We love them in the industry, and they're good. Have you seen the funny QA engineer walks into a bar shirt? No? Okay, we got to go look that one up here. Engineer bar shirt. Not shirting here, shirt. Okay, probably that one here. Let's see if that actually loads for us. Printerval. Okay, that's funny. I get it. Does that zoom at all? Can I? No? Oh, okay, zooms a little bit here. So QA engineer walks into a bar. For those of you who don't see it, you order a beer, order percent beers, 999.99 beers, negative beers, null beers. Uh, this is a Python syntax thing here with underscores, some sort of weird stuff here, other nonsense. Oh, trying to see out beers. Sure. Right. And then the follow-up joke is a customer walks into the bar, orders a water, and the bar catches on fire. Like, oh, we designed it perfect for beer. Okay. But QA engineers are good. They come up with things to try and break our programs. There was always the running joke here. QA engineers' goal is to get the programmers fired for being terrible programmers. Programmers' job is to get the QA engineers fired because they never had any bugs. It wasn't actually competitive, but you get the idea here, right? It's um, so they go through and do all the testing. So the unit testing that we can do here at the unit level in our code, we can make the computer do like we did last week, and we can do it for classes. So I'm going to go to my chair class. I'm going to right click on chair. I'm going to say go to test. It says, oh, you want to make new tests? Yes, please. Please write some code for me. I love when it writes code for me. Chair test. Great. JUnit 5 is fantastic. It says, what do you want to test? Now, again, we talked about code coverage, this idea of how much of my code is running when I'm running my tests, right? Did we talk about that last week? Ideally, we can get to 100% in our rainbows and unicorn land. All of our code is tested. That costs money, time, energy, and effort. I get it here. So the people writing your paychecks don't always agree that 100% is good. So some is better than nothing. And there are diminishing returns. If you can get to 75% code coverage, getting the next 10% costs a lot more money than it did the first 10%, right? It gets harder to catch all the edge cases. But you guys have an unlimited time on your hands, right? I knew it. I knew you had all the time in the world for just this class. You have nothing else in your lives at all happening. So we can write 100% code coverage tests. Definitely. I'm glad you agree. So we want to test the change height centimeters. That's the important one here because it's actually doing something. Testing sets and gets actually really terribly dull here. Um, but what we can do is we can actually test all of them once with our constructor. Because we know how the code was written, I know that one call to the constructor will call set color, and then I know I will set all the values, and I know that I can go get all the values out and check, did they get set to what I told them to? Now, if you right-clicked and hit generate, it probably works, right? If you typed it out yourself, there's probably a typo. So there's still some value in testing the constructor and all the get methods here. It's terribly dull, I get it here, but we're going to do it once. We don't need one test for every get here. That's okay, but we definitely want to test the change height in centimeters. That's the important one we want to test here. Okay, so it should have added that for me, and then I can say, no, I don't want JUnit 4, right, because we picked a JUnit 5 test. Make sure you add JUnit 5 to the class path, say okay. Maven will go download the package for us. It does all sorts of cool things behind the scenes. And it should work, right? I think it just took it a minute last time, right? For it to finally kick in here. Is that what happened? Did it have to like refresh it? What did I have to do last time to make it work? Do I have to run the tests? No, it doesn't give me the run option here. Hang on. We have to kick it last time, right? Generate, no. Add the class path. Said it was doing it. Okay, let's try build project. The magic worked last time and I was really happy. Why is it not working for us? Yeah.
So what did you write that the line one code? One was this Jupyter, the API, and then the assertions.
Yep.
So like, where did it write that?
So it's using this library. So it's importing this assertions library from the Jupyter API JUnit test. So this package here, we want to import. If we can make it import here. Why is it not? I need the Maven tools. Hang on, where's my? It's in here, Windows tools. Never remember where it is here. Build. When we tried build, it didn't build. Yeah, there's a toolbar I want here, and I don't see it. Where did it go? More tool windows. No, I don't want ants. It's usually right over here. I'm so sad right now. It should just work for me, and it's not. Window. View tool windows. I should have Maven in here. No? Oh my goodness. Tool windows. I'm so sad. Problems. I don't want Ant though. So Ant's another build tool that you can use in Java. We want Maven because I was supposed to be doing the package here with that one. So we added the library, right? It's there. It's in our libraries. You try run all tests. It went away when I ran the tests. I'm so sad. I don't know why it's flaky. My apologies. So all I did was tell it to run the tests. I right-clicked my project and said run tests. I think it was all there. I don't know what happened there. My apologies. Now the sad thing is change height passed, and there's no code there. So it shouldn't have passed, right? Now there's another fun school of thought when it comes to coding here and testing. That's called test-driven development. That if you know what your code is supposed to do, you can write your test first, and then your job is to write the code to make the test pass, which is actually kind of exciting. You start with a bunch of red X's, and your job is to make a bunch of green check marks to make the code work correctly according to the tests. Now, we already wrote this one for chair, so we can't start with a test and then write the code to make it pass here. That one's kind of sad. But we'll do another example where we can do test-driven development. It's very exciting, I promise. It's fun, and then it makes sure you have tests for the code because the only code you write is code that you need to pass your tests here. So it kind of helps you focus on getting the job done as well. So, but for change height, right, we're going to arrange, we're going to act, and we're going to assert, right? Set up the variables we need, test our code, make sure we got what we expect. So this is change height. We'll say valid. Here we want this one to work. So we need a chair. Chair equal to new chair given something. So we don't actually care what the color is. We don't care what the manufacturer is here. We care about the starting height, the min, the max, and their change here. So I'm going to have an int for starting height here. We'll say 100. I don't particularly care. An int for change, height change. Here we'll say is like 10. And then we'll have an int for, I don't know, max height it should be okay to actually use this plus that, right? Maybe we can do that. We'll just do some arithmetic there. So make our chair. The starting height should be the starting height. And then our maximum should be the starting height plus the height change, right? And then the minimum should be, here we go, max. Let me go down the line here. It's getting a little long here. Our starting height minus the change. Right? Is that okay? So we're going to pass it. Here's where your values should go here. So we have a chair. Now the other thing we need, this one here, is an expected height. So an expected height then, we think we're going to land at 90, right? Or I can even make it do the arithmetic. Start height minus or plus the height, right? If we add to it, right? So valid, I don't know, increase, why not? We might also want to test a decrease. I know it's the exact same code, but it's possible we typoed it. I don't know. We can test multiple things if we want here. So let's increase by our height here. And now we'll go act. We'll call the code we're testing. So then I'll make a chair, chair dot change height, and we want to change it by the height change, right? And then we need a new integer for the actual height. And is my chair dot get height. Where is the new height? What does the chair think the new height is? So we call the change code. Let's get back the new height here, and then we'll assert did they match. So assert equals a expected height and the actual height. Okay. Did it actually go up by 10 centimeters? It should. Let's find out. So let's right click and run our tests, or come back here. Witness, run this one, sure. Uh-oh, missed a semicolon. Okay, well, yeah, my test didn't pass there. Right, semicolon, try again. Run our tests. Hey, that one worked, a valid increase. We're happy, right? So maybe you also want to try decrease. So I'm just going to copy paste here. Again, probably a little bit overkill, but that's okay. Decrease, valid decrease. We'll change it by -10. Now, having a maximum be this plus that now gets screwed up though, because if I change that to -10, I've done a weird thing here. Where do we want to do this? Maybe we then subtract the height and then take negative the height. I don't know. None of these feel really good here, but that's okay, right? We can change it any way we want here to make the test work. That's not all that important which way we go about it here. But now hopefully we decrease, right, by 10 because we gave it a -10 and then height minus the height change. That should probably work here. That way I don't have to change my starting min and max here, right? Either way is okay. However you want to go about it. So I'm going to go run my tests again. I can't remember where the run button is, sorry. And both of them passed. Life is good. Right? So it goes up, it goes down. Now we want to test that it actually throws an exception, right? So this one here, we'll go just paste in another test here. So invalid, I don't know, invalid change. Sure, why not? Change. So if I try and change it, but I use the constructor that fixes all the heights here to be the same one, right? This one should crash on me here, right, when we actually call this one here. So this gets a little bit weird when we do our assertions. So I'm pretty sure there's an assert throws. So if we use assert throws, we're saying, hey, whatever I'm about to do here should throw an exception here. So we want to assert that this actually does throw here. I don't actually remember what that looks like here. I'm just going to go Google it. JUnit 5 assert throws example. Sure, we can probably get an example out here. How to do in java.com. I love it. That sounds totally legit here. So assert throws says, oh, okay, so we need assert throws. Oh, goodness. That's ugly looking. Wow. Number format exception, class, parse int. Okay. Wow. Throws exactly. Does not throw. Expected exception. We're not using JUnit 4. We're using JUnit 5. All right, that looks kind of ugly. Okay, sure. We'll try it. So assert throws then. We can get the actual exception back out. It sounds like a lot of work here. Throws exactly, does not throw. All right, sure. So our class then, and then the code we're testing. Why is that so ugly looking? Is this one any better here? Can we get any better examples? Assert throws, class. Testing a method. Here we go. This one throws an arithmetic exception, so we're going to test that it throws calculator divide here. Arithmetic exception.class. Okay. Sure. All right, we'll just copy that because that seems like fun. So assert throws is a legal argument exception dot class. So it's an instance of this class here, and now it's chair dot change height by a change in height. Height change here. That should throw an illegal argument exception, and then we should actually check that it didn't actually change our height, right? We threw an exception, but make sure it didn't change. So the expected height should be the starting height, right? Right? So we'll actually go check it out after. So did it throw, and then does the height stay the same? We can check out that one as well. Let's see if we can run all of our tests here. See if that was the right syntax. Hey, it passed. So this here is a lambda. We haven't got there yet. It's like an anonymous function call. We'll get to it later. Don't sweat it too much here. Looks crazy. It's okay. It's not the end of the world here. And you probably didn't write any throw exceptions in your Powerball class here because I didn't ask you to. And if I don't ask you to do things, you probably don't spend more work, more time doing things you don't need to do, right? You got the points without it. But I did ask you to test it, right? So feeling okay so far, right? So we can test it through that exception. Now we should also test, right? We don't have 100% code coverage yet because we haven't tested these exceptions, right? So we have to test some more constructor exceptions. Okay, sure, not the end of the world. We can test some more here. And we never did our get here that tests all of them. So we're going to add another test here. Let's go test a, I don't know, share constructor. Share constructor. So these are a little tedious here. So we need a string for the expected color, sure, we'll set it to, I don't know, blue. Doesn't really matter what we pick. A string for the expected manufacturer. Sure. Is what do we had? Toyota or something? That was fun, right? Why not? And then a string for the expected height or expected starting height. I don't know. This is expected height. Sure. And an expected max height. We'll go like 110 here because we want these to be valid. An expected min height. Again, I'm being bad. I'm not using my measurements here. It's probably not the end of the world. My apologies here. And we'll call our chair constructor. So we'll go give it all those values here then. A expected color, the expected manufacturer, the expected height, the expected max height, and the expected min height. So we'll go give it all those values here. Probably is going to work here with this one. Now we need to go test or get all those back. So now we have a bunch of gets here. So we'll have a string for get, I'm sorry, the actual color is chair.getColor, a string for the actual manufacturer is chair.getManufacturer. These are real tedious here, I'm sorry, but we just have to do it once. That didn't line up at all. Wow, why is the tabbing not working? Okay, there we go. And then for the actual height is chair.getHeight. Oops, get height. And for the actual max height, chair.getMaxHeight. And then for the actual min height, chair.getMinHeight. All right, we're almost there. Now we can assert and compare them all. So we have a expected color and the actual color. And then we'll just copy paste 5 times and go change them the expected manufacturer and the actual manufacturer, the expected height and the actual height, the expected max height and the actual max height, and the expected min height and the actual max height. Oh, that was min. Actual min and the actual max. Right, and we can run that test. Really boring, but we've got it all done here. We got all those in here. Feel pretty good about that. Okay so far? Right, I won't do the other ones that test the exceptions. You've seen it once. I don't think you need to go through it again. We've been going for a little more than an hour. Should we take 10 and come back? All right, when we take 10 minutes, we'll come back and pick it up. Let me resume. So I do need to make this quick. My apologies. My wife called. Thinks my daughter might have appendicitis, so she's going to run her up and get her checked out. So let's blip through arrays quick. They're not hard at all. Arrays fixed in size work the same way they do in C++, but you get to know the length, which is really nice. So our array syntax is the square braces here. So we actually have an array of strings called args already here. So if you say args dot, one of the cool things you get is length. It will tell you how many values are in it, which makes so much sense. I'm so sad C++ doesn't have that, and you have to do like size of arithmetic. That's so dumb. So quickly you can get the length out, but they're fixed in size. Right? They work the same way. What's easier here is using array list. So we can import java.util.ArrayList here. And an array list, very similar to a vector. So it's resizable. You can add to it, you can remove from it. It's actually easier to do than a vector because you get a bunch of nice methods here. So if I have a bunch of, we'll say like names, maybe we'll put a bunch of names in a list. So we make a new instance. So it's an array list. Now we use these greater than less than signs because this is a template type or a generic type here in Java. So this is a type of string here. We'll call names, then equals a new array list of strings. Now we can give it the list if we want here, or we can start empty. Right? Either one's okay. So starting empty is fine. So we'll say names dot, and then we can add to the end. You can add to a specific index. You can get a value out of an index. You can ask the size of the array, do those sorts of things. We're just going to call add. We'll add Eric, and then we'll add Jeb, and we'll add Journey, and so on and so on. We can put people in particular indexes if we wanted. So we can add Joy to index 1 if we wanted, throw her in as the new index 1. Everything else gets shifted down. So you don't have to use any sort of cursor or are they iterators. You just say, hey, put it here. And you can iterate over them, but we don't need to do any of those. And then you can remove stuff, right, at a given index, or you can remove by type. So remove a given index or remove an object out here, which is cool. So I can remove, say, hey, I want to remove index 1, or hey, I want to remove Joy, take her back out. Either way works, which is fun. Same syntax, it's overloaded. Now, that gets awkward if you have an array of integers, because it doesn't know if it's an index or a value. It gets a little bit funky. But in general, it works out really nice for us. So we got our array list of names, and now it's telling us, hey, we've updated it. We never made anything out of it. Like, hey, you added a bunch of values, never did anything with it. The quick way to loop through them, now we'd say for, we want string name colon names is our enhanced for loop, right? Enhanced for loop. It's our quick little syntax to go through each one, right? We can print out the name here. Sure. It's like for each value in this collection here, if you want to loop through them, or you can go by index again. For index 0, index is less than names.length, or size here, index plus plus, parenthesis, curly braces, goodness, hit enter too soon. And we can print out my names dot get here from the index, right? We'll do the same thing for us one way or the other. It's perfectly fine. And it's letting us know, hey, you could have done less typing here. So again, with the enhanced for loop, we're not changing values in the array. If you want to change something at a given index, you want to use the index loop. So you can set values at a given index here. So we can take, if we wanted to change one of them here, so I will say names dot set. What index do we want to set? Well, let's set index 0, and let's put my name in all uppercase, because why not here, right? We can change values at a given and set the index to this particular value here. Right? With our array syntax, right, it would have been like args at 0 equals Eric. Sorry, quote. Right. So array syntax uses square brace notation. Array lists uses methods here. So set here. Array index versus array list. Array list methods here. We can set and get, and they should be able to run those here. I think that'll. Oh, I'm still back on my test here. I got to change this back to main. The current file. Sure, let's run that one. Oh, goodness. Index out of bounds. Oh, had no args. Sorry, we didn't have any args here. So I can't access arg to 0. It had no length here. Sorry. Not run again. Oh my goodness. Run the current file. Sorry. And we get out all the names like we'd expect here, right? Looping through the array. So super handy. Have a little bit more features here, a little easier to use than vectors. Works out really nice for us. They're mutable. We can change them, but in the enhanced for loop, right, we're not changing the individual values here, right? You're getting a copy of them as you go. So just be a little careful with that here. If you want to change them, get the index. We can go through. I don't think there was too much more when it came to arrays and array lists. And I do got to run. Got to go check on my daughter. Apologies. So I would recommend using an array for the Powerball project. You don't have to use an array, right? But it lets you store a bunch of numbers with a single variable. I'm sorry?
Too late.
Too late, you're done already? That's okay. It's not wrong to do it without arrays, but if you want to use the array, cool. So next week, 6 p.m., I'll go over the solution to Powerball. So please don't turn it in late. When you turn it in, commit and sync to GitHub. Right? Add your screenshot and the README. I think I showed how to do that for your self-assessment, so you can see where you get the points as you go here for project 1. Right? Points for picking and validating, right? Whatever your method for that is, great. Okay. Now, if you write a method, you have to test it. So if you write a method that requires user input, it's really hard to test, right? So you want to write a method that accepts a value. Here's an argument here that you can test. You can technically test with user input. It's just a small pain. I don't have time to show it right now. My apologies. I was going to show that, how you could test that way. You can even Google it. It's not hard. You just change your standard input to be a stream, but not the end of the world one way or the other. pick your random tickets. X number of random tickets. I don't know why I put the number 5 there. I think I meant 5 points. Sorry. Yeah, can I edit that? Yeah, let's get rid of that number 5 because that makes no sense here. Sorry. Okay. And then keeping the loop, grand totals of spent, won, and lost. Again, if it shows the winning money, you've done something wrong. Right? They should not win money. The more they play, the more they lose. And then testing all of our code here. Specifically, get winnings. Ideally, everything else we wrote here. Right? It does say all, but um, again, if you had some user input, it's really hard to test that. I'm giving you a pass on that. That's okay here. Um, but at least the winnings here. Does this? How much money did I win with this ticket versus a winning ticket? However you wanted to do that here. You could pass in all the numbers. You could pass in. So I'll write a Powerball ticket class that has a method for get winnings given another Powerball ticket, which I'll call the winning ticket. Because I think that makes sense, right? One ticket should be able to tell you how much it wins if you compare it to another ticket here. So that's the way I'll go about it. It's not wrong to do it another way, but that way we'll use classes and arrays for the project here. If you didn't, that's okay. We haven't got there yet. And then next week we'll get into some more fun stuff and talk about the next project after that. We'll just keep on going every 2 weeks of the project. It'll be a little bit more interesting next time. We'll do a little bit more stuff. I think we're getting into file I/O, right? Is that, if I remember right? I really should look at the schedule here. I'm like 1 day at a time. My apologies. Just planning for tomorrow. Oh no, yeah, file IO. So we'll do some file IO stuff. I'll show you some of those cool shortcuts. We can write a whole bunch of stuff out to a file like that, which is really nice, and we can read it all back really quickly here. And what our project will be based on file IO stuff. Okay. All right. Questions, thoughts, concerns? Again, sorry to run. But yeah.
Yeah, I still arrays today.
Mhm.
Are we gonna do like actual arrays or array list?
So I will almost always use the array list because it's more flexible. Arrays are technically faster and slightly more efficient. For our purposes, I could care less. Right? We don't need any of that speed, any of that efficiency here, and array lists are just easier. So I will do everything with array lists because it just makes my life easier. Yep. Awesome. All right.
Like in the industry, do they actually use array list?
Yeah, array lists are super common. Arrays are fine if you know what the size needs to be. Like you don't need to resize it a bunch of times. You're not adding or removing from it here. If you know, hey, I only need 10 values, just use array of 10 values.
Okay.
But if anytime you're adding or removing, the array list is going to be easier to use.
Okay,
Yep.
cool.
Yeah.
Fine.
Awesome. Yep. Thanks. Take care.